So far we have discussed about the concept of atomic structure, starting from the indivisible nature of atom as proposed by Dalton, then different atomic models, Thomson model, Rutherford model, Bohr model, Planck's model, etc., and wave nature for the electrons, and lastly we ended with the quantum mechanical approach, studying revising the aspects of Schrodinger's equation as well as Heisenberg uncertainty principle, position of electron estimated in terms of 4 different quantum numbers. We have seen about the quantum numbers, the rules governing the quantum numbers. This all is studied in the atomic structure aspect. Now we will see some questions based on this. Your entrance exam questions, they are called multiple choice questions. For each question there will be 4 choices mentioned as identified as A, B, C, D. You will go to encircle against the correct choice, whether it is A or B or C. Let me read this question. This question reads as, which of the following statements about the electron is incorrect? So we got to identify the incorrect statement. Correct statement, incorrect statement. First statement A, it reads that it is negatively charged. Means that electrons are negatively charged, which is correct statement. Second statement, it reads that mass of the electron equal to mass of the neutron. Mass of the neutron. But we have studied in one pan, if you put one neutron, in order to have null deflection, you have to put roughly 1839 electrons. So one electron will be equal to only 1 by 1839th of a neutron. That is to be noted. They are not equal. Mass of electron is very less compared to that of neutron. Or in other words, mass of electron is not equal to mass of neutron, but it is given as mass. So it is the incorrect statement. Let us denote it as a cross mark. So here itself we have identified the second incorrect statement. Let us, for comparison purpose, read and check the third and fourth statement. The third statement C reads that it is the basic constituent of all atoms. So any atom consists of subatomic particle electron. So correct. Fourth statement, it is a constituent of cathode rays. Cathode rays you have studied. Cathode rays, negatively charged particle, if they are traveling the form of rays, that is called cathode rays. So cathode rays are made up of negatively charged particle. So accepting the B, A, C, D are correct. Incorrect statement is B. That is to be noted. Now the question reads as maximum number of electrons. Maximum number of electrons in a subshell. Maximum number of electrons in a subshell of an atom. Subshell of an atom is dash. Question reads in this fashion. Maximum number of electrons in a subshell of an atom is. There are 4 choices given. First choice A is 4l plus 2. Second choice 2n squared. Third choice 4l minus 2. And fourth choice 2l plus 1. Here I have mentioned only the choices. The choices will be considered as A, B, C and D. Only one choice is correct. Here n is the principal quantum number we have seen. So n can take values natural numbers 1, 2, 3 like that. Next L is the value. So n is the independent variable. Then L is the azimuthal quantum number. L takes the values 0 to n minus 1. 0 to n minus 1. Here L represents subshell. L represents subshell. We have to identify. So already we have seen azimuthal quantum number is a measure of subshell in which it is present. 0. What is meant by the 0 to n minus 1? Let us fix n equal to 2. N equal to 2 means L value 0, 1. L value 0, 1. Then third one is degeneracy, magnetic quantum number. It takes the values minus L to plus L. Minus L to plus L means that minus L minus of L minus 1, like the, it is like an integer 1 to L. So this is natural numbers, this is whole numbers, 0 starts from 0, whole numbers, this one integers. Integers means Z. So total number of values will be 2L plus 1. Let us give an example. If you put L equal to 1, M equal to minus 1, 0, plus 1. There are 3 values. There are 3 values. So it is nothing but 2 into 1 plus 1. 2L plus 1. So M equal to 2N plus 1. There are 3 subshells for p orbital we have studied. So in each subshell lastly 2 electrons. So if you have to multiply here 2 into 2L plus 1 gives 4L plus 2. So in a subshell, so total number of electrons in a subshell is 4. Total number of electrons in a shell is 2n squared. So total number of electrons in a shell is 2n squared. In a subshell is 2n plus 2. So for this question, choice A is correct. If the question is asked in this fashion, total number of electrons in a shell, if it is asked, in that case it will be 2n squared. That is to be noted. So for the current sum, the choice is A. So this finishes the thing, how to arrive at the choice. Here you got, so all the versions are given, L and M, N, S have to be noted. So this 2 is because of spin quantum number. One with the clockwise spin, another with the anti-clockwise spin, which we have studied. So this is the application of what we have studied in terms of quantum numbers. Next one is electronic configuration. So electronic configuration, there are 2 types: ground state configuration, excited state configuration. Excited state means due to higher energy content, they will move to the other shells of same energy. Other shells of same energy. That will be, so if a system will be stable, if it is having half-filled, we might have studied about half-filled configuration and completely filled configuration. In the electronic configuration, there are 2 terms. One is called half-filled configuration, another one is called complete. For example, S orbital capacity is 2 electrons. If 2 electrons are there, it is called completely filled. If it contains only 1 electron, it is called half-filled. So take the case of p orbital, 3 types of p orbital, 3 into 2, 6. So 6 electrons are there in p orbital, completely filled. 3 electrons means half-filled. If the system contains half-filled or completely filled, that will be stable, most stable. So the system will rearrange itself to have a more stable. Any process is directed towards the stability. Only system will be stable only if it is having desired configuration. So here they have given the question as, which of the following does not represent ground state electronic configuration of an atom? There are 4 choices are given. So all the choices, let me read. Only the outermost choice we are bothered about. So all the choices 1s2, 2s2, 2p6, 3s2, 3p6, up to this it is same for all the 4 choices. So up to 3rd shell p orbital it is filled. Then next to 3s we have 3d, then 4s, then 4p. So 3s, 3p, 3d, this is the arrangement. But 3s, next to 3s is 3p. Then comes 4s, then comes 3d, then only comes 4p. This is based on the off-Gauss principle. This is to be noted for off-Gauss principle. So the 4 choices vary only in the valence configuration. Valence configuration means outermost configuration. 1, 2 are inner configuration. 3 and 4 are outer configuration. First choice 3d8 and 4s2. It is reading. Second choice 3d9, 4s2. Third choice, it reads as 3D 10 4s 1. It reads. Fourth choice, 3D 5 and 4s 1. It is mentioned in this fashion. So fourth choice, into which up to 3p6. Here, if you see the periodic table, helium, neon, argon. So argon configuration is up to, so argon configuration is same in all the configuration. It is represented as capital AR, small r. So capital A, small r, argon configuration, electronic configuration is repeated and last configurations are differing, which is not possible. The question asked is, which of the following does not represent 8 plus 2? It is okay. So 3D 8 for second one, 3D 9 4s2, 3D 10 4s1, 3D 5 4s1. Here D10, D capacity, 5 types of D orbital are there. Each orbital will contain 2 electrons. 5 into 2, 10 electrons are completely filled. This one half filled, completely filled, half filled. So the second 4s2, the second electron will come inside to get 3D10. It will not be like this. If at all the configuration is 3D9 and 3D8, 4s2 is okay. And 8 plus 10, 10 up to 10 electrons filling order is correct. What happens to the 11th electron? That is to be noted. 11th electron will be 10 plus 1. So 9 plus 2 also 11. 10 plus 1 also 11. So where does the 11th electron goes? Here totally only 10 electrons. They follow only the Aufbau principle. Totally 8 plus 2, 10 electrons. So 5 plus 1, 6 electrons. No question for the first and last choices. First and last choices, number of electrons are different. But second and third choices, total number of electrons is 11. So up to 10 electrons, what happens to the 11th electron? 11th electron goes to the 4s orbital or 11th electron goes to the inner 3D orbital. Question arises. So 3D10 is half-filled, most stable configuration. In order to attain most stable configuration, 11th electron goes to the inner orbital 3D10. It will not be in the 3D9. So it is not the correct configuration. So choice B is not the correct configuration about this. So choice B is the answer. So question reads, which of the following does not represent? So second choice does not represent the configuration because of the stability reasons, that is to be noted. So this finishes the tackling up of this question. Next question reads as, it is a direct question somewhat based on what we have studied. So this question let me read, then we will see. It is based on only the concept of quantum numbers. We have studied about the 4 types of quantum numbers. The question reads as, 2 electrons occupying same orbital are distinguished by dash quantum number. Let me read the question once again. 2 electrons occupying the same orbital are distinguished by dash quantum number. In the dash they have given 4 choices: principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Already in the theory we have seen that as per the Pauli's exclusion principle, no 2 electrons can have all the quantum numbers same. Same orbitals means if 2 electrons are in the same orbital, their principal quantum number will be same, their azimuthal quantum number will be same, their magnetic quantum number will be same because they are in the same, but their spin quantum number will not be same because one spins in the clockwise direction, another spins in the anti-clockwise direction. So here the correct choice is spin quantum number. So let me read. So 2 electrons occupying same orbital are distinguished by spin quantum number, not the other types. That is, this finishes the thing. Next question. How many electrons can fit in the orbital for which? How many electrons? How many electrons can fit? How many electrons can fit in an orbital with n value in an orbital, fit in an orbital with n value equal to 3 and L value equal to 1. The question asks is, how many electrons can be fit into the orbital with n value equal to 3 and L value equal to 1. So there are 4 choices given: 2, 6, 10, 40. 4 choices are given. So the question asked is, how many electrons can fit in an orbital with n value is equal to 3 and L value equal to 1. So in any orbital, maximum we have studied immediately we will be tempted to write 2 electrons. Just now previous question we have seen 2 electrons. In any orbital 2 electrons. But there are orbitals with a degeneracy. First n equal to 3 means K, L, M shell. And L equal to 1, 0, 1, 2. This is S orbital, this is P orbital. So the electrons are in the M shell and P orbital. Electrons are in the M shell and P orbital. But we have studied that there are 3 types of P orbital: Px, Py and Pz. Each orbital can accommodate 2 electrons. Total number of electrons accommodated is 6, which gives the correct answer. It also, whenever we work a sum, if you work in a erratic manner, we will end up with the answer. That answer will also be coming into picture. So we have to be careful about tackling this problem. So for this question, choice B, number of electrons. So 6 electrons are there in the given. Now next question, last question, reads that which of the following pairs of d orbitals, which of the following pairs of d orbitals, so there are pairs of d orbitals, will have electron density. This is actually the previous question as well as this question. These previous 3 questions, 2 electrons occupying in same orbital are distinguished by spin quantum number of electrons that can be fit into the orbital with the n equal to 3 and L equal to 1. These are the previous last year questions, phase 1 NEET exam questions, phase 1 and phase 2. This also NEET exam question, phase 2. So it reads that which of the following d orbitals will have electron density along the axis. 5 types of d orbitals. They are represented as xy, yz, xz, z squared and x squared minus y squared. You have to put the d in all the cases. We have seen that there are 5 types of d orbitals: dxy, dyz and dxz, dz squared and dx squared minus y squared. Xy means in this pattern. You got to be careful about the noting. This is x-axis, this is y-axis. D orbital is having 4 lobes. D orbital is having 4 lobes. The 4 lobes are situated along the xy plane. Xy plane means, but the lobes are not along the axis. They are diagonally with respect to the axis. They are not along the axis. The question is, how many d orbitals are along axis? That is the question. There are 2 d orbitals along. Out of 5 d orbitals, only 2 of them are along the axis. Which are they? Questions are asked. So we got to be, so different choices are given. One of the choices is these 2. dxy, it is not along the axis. So if you write y and z, it will also be in the diagonal fashion. You got to remember xz. So for understanding purpose, I have left the third axis. Not that third axis does not exist. xy means xz is existing. Yz means x is existing. That is, our aim is how it is distributed. But here dz squared is distributed along x axis and z axis. two lobes are along z-axis and two lobes are condensed as a ring, like a Saturn ring, along the x-axis. So dz squared, the lobes are along only the z-axis and x-axis. Last one, dx squared minus y squared. Here also this is along the axis. So these four will look alike. All the four lobes will look alike, but how they are distributed, they have to, if they are diagonally distributed, it is represented xy, product, x and y, y and z. If they are distributed along the axis, it should be represented as x squared minus y squared. So these two are the orbitals which are positioned along the axis. Out of the 5 orbitals, so first choice reads as dz squared and xz. dz squared is correct, xz is not correct. Second choice reads as dxz and yz. They are not correct. They are not along the axis. Third choice reads as this one, correct choice, dz squared and x squared minus y squared. Fourth choice, xy and x squared minus y squared along the axis, xy is not along the axis. In this way you have to be noted. So this finishes the tackling. So in the positioning of d orbital, you have to remember that lobes are positioned along the axis only for 2 versions. Other 3 versions, they are distributed between the axis, diagonally opposite to the axis. That is to be noted. Now we will see the last question in the atomic structure, that is electronic configuration. This question reads as the electronic configurations of 3 elements are given. EU means europium, all are synthetic elements, F block elements. EU is europium, its atomic number, within bracket atomic number is given. Atomic number is denoted by the letter capital Z. So europium with atomic number 63, GD gadolinium with atomic number 64 and TB terbium with atomic number 65. Their symbols are written for these elements, europium, gadolinium and terbium. So atomic number means number of protons or number of electrons. Now we are bothered about the electronic configuration. So the system contains respectively, europium contains 63 electrons, gadolinium contains 64 electrons, terbium contains 65 electrons. All the electrons will be outside the nucleus. So they have to be, all the electrons have the same charge. Each electron will repel one another. So it has to be properly positioned. That describes the electronic configuration. Here the electronic configurations are written in terms of the nearest inert gas. So the inert gases are helium, neon, argon, krypton, xenon, radon. Xenon electronic configuration, xenon atomic number is 54. So all these elements have the atomic number higher than 54, which means that up to 54 xenon configuration is repeated for any element. So it is written, the electronic configuration is can be written in this form also, instead of writing every time 1s2, 2s2, 2p6, starting from every time. Instead of nearest inert gas configuration will be repeated. Xenon means, so xenon atomic number 54. If you add plus 54 plus the power, here it is not actually the powers. These denote the number of electrons in the respective orbital. 4f orbital contains 6 electrons. 5d orbital contains 1 electron. 6s orbital contains 2 electrons. Here you got to bear it in mind, xenon 54 electrons. So 54 plus 6, 60, 60 plus 1, 61, 61 plus 2, 63. That is its atomic number. So in this way it has to be, it is arranged. But anyhow, 4 choices are given. The electronic, here the electronic configurations are, the question is the electronic configurations of europium, is that equal to 63, gadolinium, is that equal to 64 and terbium, is that equal to 65, or 4 choices are given, but only 1 choice is correct. It is a multiple choice question. So only 1 choice is correct. Which choice is correct we have to identify. So as you look, all of them will appear to be correct, but here we have to follow the rules to write the electronic configuration. Above principle, Hund's rule of multiplicity, Pauli's exclusion principle. Aufbau principle states that electrons tend to fill in the increasing order of energy level. So, in the 1s, 2s, etc. up to 3p regular. Afterwards, 3p, next to 3p, next level, higher level is 4s. Then only comes 3d. 3d level, even though inner, its higher energy content is higher. So, as per the Aufbau principle, 4s level is of lower energy compared to 3d level. Similarly, 6s level, 6s is the outermost orbital, 4f is the innermost orbital, middle one is inner orbital. So, here inner orbital energy is maximum, 5d is maximum, outer orbital energy is minimum, that is to be noted. 6s energy level less than that of 4f and less than that of 5d. What is the significance of this level of Aufbau principle? So, here electronic configuration has to be written, or electrons tend to fill up in the increasing order, means that if you write in terms of energy level, first 4s, then 3d, first 6s, then 4f, then only 5d. So, this is the increasing order of energy level, but you should not confuse with these numbers. 6, 4, it may appear as though 5 is the topmost. It is not like that. 5 represents the inner shell, 4 represents the innermost shell, 6 represents the outer shell. Outer shell has the lowest energy. So, if you up to xenon, it is correct. Xenon means 54. Up to 54, it is correct. What happens to the 55th electron to 63rd electron or 64th electron or 65th electron? How they are getting filled? That is to be noted. Everywhere also 4f, 5d, 5, 6s, 4f, 5d, 6s, 4f. So, in some cases 5d is not there. That is to be noted, which is to be identified. Here in this way, first 6s is to be filled. So, first one is European, 63 out of 63, 54 have been filled. Remaining 9 electrons. 9 electrons, next to xenon, 6s has to be filled. 6s 2. 54 plus 2, 56. Balance 7 electrons. 7 electrons go to next higher level, 4f level. So, f orbital, 7 types of orbital, they tend to remain unpaired. The Hund's rule is also to be followed. So, in this way, it is correct. 6s and 4f. 5d orbital will be there, it is empty. 5d orbital is there, but it is not filled with electrons. This is the case of Europium. Next, coming to gadolinium. Similarly, in the manner, for 6s and 4f have been filled. The question may arise, half filled, next filled. Half filled, they tend to remain unpaired, innermost shells. So, innermost shells means they tend to remain unpaired. Next to 4f, it will next electron will not go to 4f, 8. Then, because 6s have already been filled, 5d, next electron goes to 5d. So, 63rd electron, up to 63rd electron we have filled. 64th electron go to 5d orbital, the 5d1. That is the correct electronic configuration of gadolinium. Lastly, Tb, capital T, small b. Tb means terbium, T-E-R-B-I-U-M. Its atomic number is 65. So, 65 minus 54, 11 electrons are there. 11 electrons, 6s have been filled. Then comes to 4f, 9. So, 11th electron also, when it comes to the case of 11th electron or 10th electron only, the f orbital is getting paired. Till then, f orbital will not be getting paired. Here simultaneously we have to follow the two rules of Aufbau principle, that is the increasing order of energy level, then off-field configuration. Because what is meant by off-field configuration? F electron capacity is 14 electron. 14 by 2, 7. 7 is half-filled. It tends to be remain half-filled is the most stable. That is why 4 of 7. So, there is no 4 of 8. It will not. 4 of 8 in some it is given. 4 of 8 it is given. We will be tempted to write 4 of 8. 4 of 8 will be rearranging to get 4 of 7 and 5d1. What would be the case? That is to be noted. Because of the higher priority of half-filled configuration, first 4f is getting filled. So, as per this order, choice C is the correct one for this electronic configuration. Others are not there. 4 of 8 means it is not half-filled. 4 of 8 is not half-filled. That is to be noted. F means it is 7. F capacity, 7 types of orbital, 14 is the completely filled, 7 is the half-filled. Half-filled configuration preferably it takes. If it is not possible, it takes to 4 of 9. That is to be noted. That is the idea. So, others you can leave. So, they will give in this manner. We will, our general expectation is that 54 minus 11 as per our wish we write. It should not be the case, we have to be followed. So, we need not bother about whether 5D is getting filled or 5D has no electron, no botheration in that. Our aim is to have the stablest system where half-filled configuration is the most stable. F electron system 7 is the most stable. These points are to be noted. As to following these points, choice C is the correct configuration. We have to patiently approach the system so as to arrive at the choice. Where it is it XE 4 of 5D 6s like that. You have to first segregate first 54 electrons, segregate as xenon electronic configuration. Then what happens to the remaining 9 electron or 10 electron or 11 electron? So, for this filling up 9 or 10 or 11 electrons, you have to bear it in mind the two rules, that is Hund's rule of multiplicity as well as half-bow principle, that is to be noted. This is with respect to the electronic configuration of heavier elements, higher elements. So, generally electronic configurations of higher elements are reported in terms of nearest inert gas configuration. Instead of writing from the starting from the top. Starting from the beginning, you cannot write 1:1:2 in this way. Here itself, it takes the longest chain. So, it for 63, for 64, for 65, you have to write like a paragraph. It should not be the case. So, it is better to condense in the form of nearest inert gas configuration.